Okay, I should be visible and you should be able to hear me, folks.
Yep, I got you.
Okay, so what we're going to look at this morning is we see a lot of specifications now coming out, and the topic is the fact that many of the manufacturers, the generator set manufacturers, are offering their onboard paralleling solution. And what the main point of this is, and this is hopefully going to be just a factual based set of comments, but we're going to show you what we feel. If there's some errors, please bring it back to us and we'll correct the presentation. But we're going to show you where you start with their simple onboard paralleling systems that may be totally satisfactory to some of your specific projects or such. However, there's an intermediate one that we really want to sort of bring to your attention, that even though the generator sets may be doing the paralleling, we're going to introduce a master control section, and there are reasons why we're going to go that direction. Still allowing the genset people to do the paralleling. And then finally, we'll look at our traditional paralleling switchgear. And as Mumtaz said, we're going to go into that a little bit with the intention of being a much deeper dive in a future presentation or such. Going to touch on just some preliminaries in a minute. What is paralleling? Why is it required? We're going to refer to these three blue terms: non-resilient. That is just a simple generator sets parallel to a common bus. We'll explain those and maybe some of the applications as to when that may be totally acceptable to your client. The resilient is sort of our middle tier, which we will refer to as a load management system. They're still doing the paralleling, but we're going to put a master control section on top of that. And then at the end, the redundant and resilient is what you know as traditional paralleling switchgear. All right, so why do we parallel? I think this is very common, but obviously you've exceeded the capacity of one generator. Or due to reliability, you may want two or three generators so that you're not relying on just a single source. Now, you'll notice on the left-hand side is that we are going to tell you, at least in some of the applications, and I have actually a code reference at the end of this presentation separating your life safety, your critical, and your optional loads. That's what's sort of displayed on the left side. Obviously, it's the standard single bus application. Someone's doing the paralleling to put those two generators online. Now, we point out on the right side that you may have a segregated bus or a split bus system. Many times this comes into fact when we are doing medium voltage. And the reason we do that is that each of the left and the side branches, buses there, they may have emergency loads, critical loads that need to be on. I'm sorry, life safety loads that need to be on in 10 seconds. Well, in doing so, we're able to close that first generator on either side, meet that requirement. Once all generators are online, all of the transfer has been taken care of, then we will start evaluating how many generators are really used. Keep this picture in mind, because as we go into some of the reasons that a onboard paralleling may not operate, we're going to point out that they do not seem to operate quite well using a tie breaker. Just to kind of give you those parameters, when we're doing paralleling, we need to have a frequency of zero point 0.2 hertz. We need to be within 5 electrical degrees, and we need to have no more than a 5% voltage difference. We're also going to point out to you that in breakers, closing those breakers, they must have a 5 cycle, very repetitive closing ability, because that way we are closing while we are still in the window of acceptance. According to Consulting Specifying Engineering magazine, scalability and expandability obviously is there. You know your certain capacity now, you need something future. And then really the second point we like to drive home is the fact that with redundancy, it eliminates a single point of failure. And more importantly, by having multiple, possibly all the way up to N plus one systems, which is the number of generators needed to meet your load plus one additional, you're almost up to 100%. You're at 99.96% reliable. The efficiency by optimizing the generator loading. We do not want to do two or three things with you folks. Number one, emissions. Number two, noise. Number three, fuel. We do not want to underload your generators and have them go into a slobbering condition or such, specifically with diesel. In any case, we still want to run your systems optimally. And then the load management, the load demand, and bus optimization. We're going to touch on that for a minute today, but it's the intention for Mumtaz to come back at the next one and deep dive into that discussion for you folks. When you're looking at economy, generating on-site power to offset utility. One of the gentlemen asked at the beginning where we're located. I'm actually down in Houston, Texas. We have our own utility grid here that is ERCOT, and we are stretching it. So now they are reaching out to customers such as Rice University was one that they want to put you on one of those interruptible rates. And in doing so, they'll pay you money in order to be online to have some type of a demand response or such system. Maybe your clients have that. We'd like to discuss that with you. If that's an opportunity, we can work with you. Maintenance and serviceability. We're going to seriously touch on serviceability because at the end there is a reference to the code that says if you have an emergency system and it is backed up by a single generator, you have to have means to have a roll-up generator available while that service is being done to that on-site generation plant. We're going to look at priority load controls per the NEC. We looked at load demand, supplying the loads using the fewest generators. Again, the Mumtaz is going to pursue that at another time. Load shedding and bus optimization we can touch on is the fact that we want to keep as much load online at all times. And there are several ways to look at that. We would like to deep dive into that a little bit further on the next session. The increasing the redundancy by possibly having bus segregation, as you see down below. Compliance. If you are a healthcare facility and you need to have your JCO reporting, this is something very critical now, and our system can allow you to have components that will generate those compliance reports while you are running your monthly, semi-annual, annual testing and such. Some of the main things is, again, we look at the same two little one lines down below, but in the bottom right-hand corner, once you have gone to an onboard paralleling scheme with a specific manufacturer, you are typically tied into any future generator sets needing to be provided by that same manufacturer. Whereas if you take it to ASCO, we're agnostic. We can work with anyone's generators. We can parallel different manufacturers. Just a side note that I always like to point out to the consulting engineering community, we need to be sure that the pitch, if you do not understand what that is, reach out to us. But if the way the generator is wound is a 2/3 pitch, each additional generator needs to be of the same pitch. Just to digress on that for a minute, why? Because a 2/3 pitch generator will minimize the third harmonic, whereas, say, if there is such a thing as a 5/7 pitch, it is eliminating or reducing the seventh harmonic. The primary voltages at 60 hertz will parallel, but because of those two differences, you have circulating current. We can attempt to minimize it with our voltage regulation and such. We cannot eliminate it. Complete different topic, but it is something that we would like to pursue with you if we need to explain it better. Again, I'll say the same thing, Mumtaz, or if anybody needs to interrupt me, please do so if I get going too quickly or such. When you look at the speed controls, they have gotten a lot more sophisticated from the old 3-meter panels or such. Many of these speed control devices now, you see a Caterpillar and you see a Cummins on the side there. They do the speed control. The voltage regulation may be already incorporated in there. Many of the protections are already in there, the generator metering and the onboard paralleling. That's fine. We can work with that. Now, the devices that you see down at the bottom, should you go into where the generator paralleling switchgear folks are doing the paralleling, now we do what's called dead bus arbitration. In either case, it's a dead bus arbitration. That term means that should your utility power go down, at that moment, there is no power on the emergency bus. In a typical system, you will send a start signal to all generators, each generator, and simply by the laws of physics sort of decide and say one of those generators will hit the bus first. In doing so, it will energize the bus and give a reference of voltage and frequency for each subsequent generator to close to. That's referred to as dead bus arbitration. In the case of the devices below, yes, the paralleling gear is doing the synchronizing. Now, the device you see there on the D-Slick 2, and I believe there's a newer model, but the D-Slick 2 is the digital synchronizer and load control, whereas the other two devices to the right side are the older components by Woodward. There was an SPMA synchronizer, and there was a load sharing module. Again, a point I like to point out, we can parallel. The system can parallel a 2000 kW, 2 megawatt unit with a 1 megawatt unit. They do not have to be the same kW. We simply do that by loading each of those to the percentage. 50% may be on each. So there is no reason that we cannot look at those and absolutely work with you. A comment to you is that if you are reworking a system and you have existing generators, please get as much information as you can from the field. What are the control panels? What are the voltage regulators? What are the governor systems? It will help us coordinate with you folks. Obviously, also, when you are doing paralleling, you're going to have your NFPA test that's going to have to be run on each one of your generator sets, okay? Well, at the end of that, the paralleling switchgear folks need to utilize that same load bank in order to set up the load sharing. If you're doing parallel with utility and we're doing a VAR or a power factor correction, we may also recommend to you to have a resistive reactive type load bank to set up those VAR controls. Another side comment, folks. So when you start into what we're speaking of today, non-resilient, light commercial, it's an onboard paralleling system. Many of the manufacturers, we're going to show those, do that. There is a simple wall-mounted master, and then usually that system connects to a main lug only distribution switchboard of some type, usually of an 891 construction, and you can see somewhere between 250 kW and 750 kW is the typical range for these systems, 2,000 to 3,000 amp main bus. Well, what does it look like? So you have each of your generators. In this case, we're showing you Cummins. They seem to have themselves together quite well doing this. And in there, you see that there is a controller on each of the generators. That's your HMI type screen or such. And each of those components listed there are available to you. Then that goes into some type of genset controller, and that is what's doing the synchronizing, the load sharing and such, and eventually coming over to the engine control module for the governor, the engine protection, and the engine metering. The point is that if you'll notice, those are connected together by a single data link. And that may be a single point of failure. In the right application, you may not be concerned with that. At a higher level client, that may be something that you want to consider. You'll notice here that they do have a little wall-mounted master. We're going to have a better picture of that. And typically all that does is comes into some type of main lug only distribution board. That may be a concern to you because there's no main breaker should there be a fault to that board. Caterpillar does something very similar also. It uses their onboard controllers, their EMCPs. They go into some type of a wall-mounted master. And since they are partly owned, their system is partly owned by Eaton and such, they may have an Eaton distribution. Again, you notice this is just a main lug only type construction, 891, and you may be concerned about that. The same thing with MTU now. MTU does a very similar thing. Sometimes MTU will reach out directly to a Square D or an ASCO or such to do the distribution portion for them. Well, what are we looking at? Here's the major manufacturers that we've sort of identified. Obviously, Cummins, Caterpillar, Kohler, MTU, and Generac. Generac plays in this market. They've been quite successful in some of their smaller arrangements and such. And what we're pointing out here is this is the controller that you're relying on. Sometimes as small as 6 to 15-inch screen of some type, and it may be limited in its characterization, maybe just in black and white, and not necessarily give you a real dynamic one line or such. Now, the reason I pointed out that main type board before, these systems do not operate with a tiebreaker. The intention is they need to see a single bus. They need to see all generators online so that they can do their paralleling and their load sharing scenario. We're going to repeat this process over and over again, and I believe Mumtaz is going to make this available to you. But as you go from the basic, the non-resilient application on the left, resilient in the middle, load management scheme, intermediate, and then the full paralleling switchgear to the right, the redundant and resilient, you can see functionality that is either not available, optional, or may be of a concern to you. In the case of the non-resilient, you notice there is not room for any type of redundant PLC. In the resilient or the column to the right, it's either optional or to the right, it's standard. Some of the things that bother me the most is when you're looking at the factory test and sequence of operation, that simple system is wired and tested in the field. Whereas the other two, and specifically we can go into that, but we will go through all of the factory testing. You can attend a witness test either virtually or actually in person. We will go through the complete sequence of operation and debug the system before it would get out into the field. So the NFPA enunciation, when you look at the left column, no, you're simply getting the unit mounted generator enunciator. Whereas when you come over to the right side, you may have a full-blown set of lights, meters, and reporting available to you to meet all of the NFPA requirements. Well, why are we concerned with this, folks? It's simply to point out to you, if you have these two generators and you're connecting them to a main lug only panel, you may have a point there that you're concerned with. Should you have a fault, you've taken out your whole system by not being able to clear a main breaker or by having it just connected in this capacity or such. Again, no matter how complicated the system becomes, I'm still showing that those two generators are connected to a main lug only bus. And in that case, it typically is not in control of that tiebreaker. How is that tiebreaker being controlled or such? And kind of getting to some of your NFPA and your NAC requirements, the engine start wiring. You notice that in this case, because of the limited amount of space to bring those wires into, all of these transfer switches are daisy chained with their start circuit, bringing in a single set of pair of wires. Well, if you need to have those separated out, you may have exceeded the capacity. In the case of when you're also doing, the reference will be at the end, you have to monitor each of those start circuits so that you know that if any one of those are broken open, according to the NEC, it is going to start the generator to notify you that you've lost that start signal. In this case, if you've broken that daisy chain, you may affect many more switches downstream or such. That's sort of the overlay of the simple, basic system of onboard paralleling. If you move a little bit further, either ASCO or some of the manufacturers we're going to show you are going to give you a full-size master. You'll also notice that before we were looking at an 891 construction, We are going to reference now 1558, even though you can do either of those. If you're not familiar with it, please look it up. We've got a couple of pictures later on in this presentation to sort of illustrate the difference between an 891 and a 1558 construction. These typical systems are anywhere between 500 to 2 meg generators, and you can see now that we're all the way up to a 10,000 amp bus. That's the maximum of the major manufacturers now of paralleling switchgear. That's as large as ASCO goes. How do we compensate for that? We go to the segmented bus sections where we have 10,000 amp on each section, and therefore we can put the number of generators that you need into your system. Well, what got added? If you'll notice now, Cummins here has a master control section, and now they have introduced a much nicer looking HMI screen or such. They now add this. Each of the generators come in. The system is still being paralleled at the generator sets, and they feed into some type of a distribution board. This one is 1558 construction with draw out breakers or such. But now we have given you more real estate, more room. They have capacity to do additional functions should you need to. Okay? Caterpillar does a very similar thing to it in the fact the only difference is if you'll notice to the left side of that 3-section lineup, they are utilizing a dual gen section. Obviously, we're saving space, we're saving cost, we're saving money or such, okay? But you'll notice now that you do not have any of your analog meters. You're relying totally on that touch screen to see what is going on. And if that's acceptable, it's just pointing out those differences to you. Obviously, protective metering and relays can be added to this type of a Caterpillar lineup or such. When you look at MTU, MTU has typically come to ASCO to assist them with this type of product. They will use our master control section and distribution section, and all of those tie in, but you are still relying on the generator set in order to be able to do the paralleling. However, notice now by coming into an ASCO section, those tiles, which we will show you in much greater detail, are there for your NFPA enunciation of alarms and shutdowns. You now have analog meters available to you. You have a larger touch screen. The system down in the bottom there in the bottom left where you see the little red and green button and such, that green button is actually a manual paralleling scheme if that is invoked into this. And then obviously any type of power metering or TDI display or something that may be required. ASCO has what's called a 947 loads management switchgear. I alluded to that in a little bit earlier. That is our intermediate. It provides ASCO load control expertise and our competitive differentiator. What do I mean by that? By letting us do. You can do the paralleling. The paralleling is fine. You've taken your 2 or 3 generators, you put them on. But what functions do you need beyond that or such? Well, you may want load control. You may also want to do your load demand, your priorities, your load add, load shed, standard bus optimization. Let me just touch on those for a minute. When you do standard bus optimization, and again, we'll deep dive the next section, you are going to hard code in each of your transfer switches. You're going to tell me that this transfer switch is approximately a 400 kW load. This one is a 600. Okay? Why do we want to know that? Well, should you have an if you put too much load on your generators and you take load off, we're going to evaluate, well, what can be added back on? Well, if you're hard coded, that's the value we need to use. Whereas if you go into the other one that was alluded to at the beginning, dynamic bus optimization, you have a meter on each of those transfer switches that read that value. You may have told me it's a 200 kW load, but I know you're only pulling 70 kW traditionally through that switch. This is a very good differentiator with ASCO here. Emergency power applications. This one is typically based on an 891 design. It is configured to order 891 because you'll notice there isn't some type of an I-line panel board or such. If you're not familiar with 891 design, you can put 489 breakers in there. You can exceed that capacity by going to 1066 breakers. However, once you've gone into the 1558, and we're going to touch on this in a later slide, you have to have 1066 breakers. 489 breakers are not allowed. It must also be compartmentalized, and each breaker must be individually in their section and isolated. The 947 switchgear system looks like it does here. You obviously you still have a master controller. You may still have generator sections. That's what those three show you there. And then the distribution or such. Now the load management over to the right side, as you can see, we do not have all that metering. We've taken those three sections, section 2, 3, and 4, and we have combined those into section 2 where we have the breakers for each of those and some type of metering, but you do not have all of the controls in there. And then obviously the load bank section and going into your distribution, including some type of an I-line panel or such. We want to discuss this with you. Sometimes footprint is very much the point that we need to try to assist you with. Please bring it to us. We would like to take a look at it. This is a means of still working with the onboard paralleling scheme, but giving you those additional features that may be required by the client that you are. If you're looking into the hospital itself, a major hospital, you may have very stringent requirements. Well, if you're in a satellite facility or the medical office buildings or such, you may be a little bit more relaxed. That's what we want to look at the differences for you. We do not want to oversell. We want to meet your expectations and possibly point out some things that may be valuable for you to consider with your client or such. The master control comparisons. Okay, now you're looking at each of the three. Redundant PLCs on the left side, no. The load management is optional. Yes, we have room. We can put redundant PLCs. The touch screen, obviously, we're up to 24-inch or such. We're back to the sequence of operation tested. You'll also notice that the analog meters on the left side, you cannot get them. However, in the intermediate or the resilient, yes, you can get those. They're standard on the right-hand side. A best battery system. Best battery system is going to take each of your starting generator systems batteries, and they are going to use those, and through a best battery system, we are going to keep that DC voltage up in order to maintain all of our protective relays and our PLCs from not dropping out while you're cranking those engine generator sets. Hardwire backup logic. We're going to stress that to you in order that if you have lost your controls, if you have hardwire backup from each of your individual transfer switches, should you have even lost some of your advanced controls, that will still send the start signal, and at least your priority one loads will be put online by a hardwire backup scheme. And each of the others you can go through. We would like to discuss these with you after you've sort of digested these questions and points and bring them to our attention or such. Well, when you look at the differences, and again, these are taken from each of their websites or such. Over to the side is MTU. You can see it's a 15-inch screen. As you move from right to left, you go to the Caterpillar, Cummins, and then into the ASCO system. These are our master control sections. How much information do you need? How easily do you want it to have someone walk up and just get that information? If you're comfortable scrolling through the HMI screen, that may be satisfactory to you. However, due to the intention of the installation, you may still want all of those NFPA tiles and all of the analog metering that is shown in the ASCO. We're going to show you a little bit later on also that we tried to give you the very best visual of your Dynamic One line as shown on there, color coding it, and it's a pretty easy display to read or such. Without going into too much detail at this point here, all of the devices below may be needed to be communicated back to some type of either an on-site or some type of a cloud-based system. Obviously, we work in association with Schneider Electric. They have their power monitoring expert, PME, that can either be on site or can be all the way up to a cloud base. In doing so, you need to have the right components. You need to have the correct metering. You need to have the correct the devices in order to bring all that information in. Another comment they're just noticing here that you see in office, engineering office, and BMS. Typically, most systems communicate via Modbus. However, should you need BACnet or so, that can be accomplished by ASCO. And it's just one of those things that obviously you see in the middle tier here that the Modbus TPC or BACnet is optional when you go to an onboard paralleling scheme with a master control section. A little bit of difference to UL 1558 and 891. So this one here, we still get asked these questions from you folks and from the folks out, the electrical contractor or such. They still refer to it as switchboard or switchgear. Well, when you see our drawings come to you from ASCO, we always refer to it as paralleling switchgear. However, it may be an 891 construction, just our terminology. Well, what's the difference? Dead front required, no requirement. Let's look at a few of them. If you go to a switchboard construction, okay, that is an 891 paralleling switchgear scheme. You're limited to you're limited to 6,000 amp bus maximum. However, once you've gone to our 1558 construction, it says no defined limit. At this time, most of us, including ASCO, are limited to 10,000 amp bus. The short circuit is a requirement, as you can see, either 3-cycle or 4-cycle. And one of the main things is, in order to pass that 1558 label, you have to hit that 2 times. 5 seconds on, 15 seconds off, 2 times, and pass without destroying the gear. And that's how you get your 1558 label. In the case of circuit breakers, as we've stated, 489 molded case, insulated case breakers are allowed. You can exceed that by going to a 1066 breaker. Those are power circuit breakers. Many times when we're looking at an 891 construction, you may have an 80% rated breaker. In the case of 1558, we're going to give you 100% rated breakers. And then the bottom line is the serviceability of parts. And in the bottom right-hand corner, that less than 5-cycle closing is absolutely imperative so that you close in that time of that you're in the acceptable window. If you've ever walked up to a synchroscope and watched it go around, it's got to be moving at a reasonable pace. If it is so far out of synchronization that it's moving through that window of acceptability too much, too fast, you are not going to be able to close that. Another comment is that if you are doing the onboard paralleling, they're doing all of the biasing to their governor and to their voltage regulator. Whereas if you come to our final comment here, when you're going to the redundant and resilient, we are controlling that. We need to know what system you have, and we are actively controlling the synchronization of those systems. If you haven't ever walked up to one or had the opportunity, again, please come to our witness test if you have a project that you're available for. But on the left side, you'll notice that this is an 891 type construction, and you see that it is open. You can see between the sections, it is not compartmentalized. Should a fault occur, you can damage multiple sections, multiple cubicles of each of that lineup or such. As you move over to the right side, you will 891 distribution equipment. If this were UL 1558, the panels would be separated. The front of the enclosure from the rear and side would be enclosed on the left side. You would not be able to see those breakers on that side. Choosing UL891 is a wider range of breaker types, as we've stated, compatible equipment, and potentially lower cost in doing so. The other thing I'd like to point out to you is when you're doing some of your projects, please let us know if your breakers, your distribution breakers, are to be electrically operated or if manual operation is acceptable to you, because that allows us to stack a certain number of breakers. With manual breakers, we can stack up to 4. With electrically operated breakers, we may be limited to 3, depending on their ampacity, in order to house the controls and the switches and such. While we're on that subject or such also, if you're writing your specification, do you want an energy management reduction, EMRS system? Do you want that? If so, please clarify that to us. Do you need it individually? Or can we have one switch that puts all breakers in that situation should you be in a maintenance mode or such? As you go to UL 1558, highest voltage and fault current ratings, a short time rating can be considered. We can go with these up to 100,000 amps bracing. We can also do 200K bracing or such. If you do this also and you have all of your breakers this way, you may open yourself up much easily to selective coordination. That is part of the things that is pointed out on that little chart that we've alluded to a few times. Selective coordination can be something that we want to discuss with you not only in the paralleling switchgear, but just as a side caveat, we would like to discuss that with you when you're looking at withstand and close-on ratings and the time that a transfer switch downstream needs to be able to survive that fault. Typically we're at 3 electrical cycles, 0.05 seconds there, but depending on how your coordination is, that transfer switch may be exposed to that fault for beyond 3 cycles. We understand that, but you may not have to take that all the way out to a 30 cycle rating. We want to discuss that with you if that's something that we need to clarify for you. The case studies. So here we are. You saw this one a little bit earlier, but the original design showed just as we did. And we're back to the same comments that it was a main lug only distribution and there was a tiebreaker and the engine start wiring. By going to the revised one, you can notice now that to the left-hand side, we have added breakers that we are going to control to bring those incoming generators in. And in doing so, now we have to add a master control section, and we are able to control the utility breaker or a tie breaker should it be in there or such. Each of the transfer switches downstream are still shown, and at this point they're shown to be daisy chain, but we would like to discuss that with you with hardwire backup or such. So we have a 48-inch deep system. There's a generator section you notice to the left. We are utilizing I-line panel boards. Obviously, a master control section is still in there and duplicated over to the other side. Please bring us your space limitations. We have options for you that we would like to discuss with you and have those opportunities to put that in front of you. Finally, we get to either a redundant or resilient application. Now we're all the way over to the right-hand side. Many things have become standard, okay? And you can go through those, and we would like to discuss those with you if you need to have further explanation, just to not get into there and take up too much of your time today. Looking at a difference between a couple of the manufacturers, the one on the right is Russ Electric, who is one of our better competitors, and over to the left is the ASCO system. We seem to feel as though you get a lot more visual from our system on the left. It is a dynamic one line. It changes colors. It also gives you indication of where the system is and how it is operating at this point. And it's very easy to go through. All of the buttons down at the bottom will walk you through the enunciation points, the alarm points and such, and you can gain a lot of information from our screens. Once you come into a full-blown synchronizing system where we are doing all of the synchronizing, we now have the synchronizing controls. We have master control, and we're in 1558 construction. Well, what have you gained? Okay. When you go all the way to this level, if you notice down below in the master section, we are going to give you redundant PLCs, hot swappable. They are running at the same time with each other. Should your first PLC go down, the second one is already at that step, and you do not see any interruption in the situation in the sequence that's going on. As you look in each of the generator sections, we also provide you a generator PLC. Should you lose your master PLC, the generator PLC is still in control and will perform functions that need to be done to put the generators online safely. Above that, you notice again, we're using the digital synchronizer and load control. And in this case, we are doing a duplicate landline. Should you lose one of the landlines, the second one will immediately pick up. And again, you will not have any loss.
Daniel, I think you got muted.
Okay, back to if you look at this here and you see that we have dual lines, I don't know if that's where I got muted, the dual landlines or such. Should you lose one of your communication lines, you have the secondary one that is going to pick up and your system will continue operating. Back on that home screen that you were looking at, the OIT, that has a very clear screen that you can look at to see that you've lost the LAN, which one is in control. In the case of your master PLCs or such, which one is controlled? Are they both communicating and such? Should you lose both of your master PLCs, the generators will start and your priority one loads will be able to transfer to emergency. However, since you've lost your logic beyond that, you do not have control to be able to release your priority 2, 3, or 4 loads, sort of to say. We can give you that in a sequence of operation. We can describe that to you better, and we can go through that. This is the most redundant system, redundant PLCs in each of the generator cabinets, and a redundant communication between each of the D-slicks. So when you look at this here, you have the PCS synchronizing, master control, and UL. This again is by one of the other manufacturers. And here's another comment I like to point out to you. If you look down at the bottom here, it says typical wiring, 10 number 14s and 3 number 10s or such. When we give you that call out, we may be trying to get as much information as we can from the communication link. But many of these hardwire enunciations and such, we're still relying on wires coming in. So we may
Daniel,
take as much. Yes.
I got a question. The system also has a function, I'm sure you do, to text message or send a message to, yeah,
Yes.
does?
Yes, we have a red line device that is typically in our system, and it'll do the text messaging and such, or some type of call out or such that you may need to. Yes, sir. We have that capability.
All right, thank you.
No, thanks for stopping me for a minute. Appreciate it.
Sorry.
Generator control redundancy, we've touched on that several times. We just want to drive it home to you. And the most important thing is that you're not locked into one single manufacturer of your generator sets. When you look here at the control panel, okay, you start off, you now have these enunciation points that is required by NEC and NFPA. Those are in a typical master section. You have, as I said, a redundant PLC in each one. We are still giving you the analog meters, whether or not that's something that your client requires. It can be shown simply on the OIT screen if you'd rather do that. Each one has a D-slick, as we pointed out previously. Obviously, we can give you any type of metering. We obviously, the one on the left side that is shown, that is an ASCO meter, our model 5210. Should you need additional information to that, we go to the Schneider meter, either the PM5000 or PM8000, and I will even tell you, if you want somebody else's meter, bring it to us. We are able to do that for you.
One more
Best,
question. I'm sorry.
sure.
Do your meters have the capability of detecting monthly or yearly the uh, the peak loads of each ATS or the generator that it has, or and can that be printed out into a document?
I believe the answer to that is yes, and the reason I say that is I was on the phone with one of my service technicians just yesterday or the day before, and that was a point that was actually brought up or such. But to answer you more correctly, if Mumtaz will take that down and address that for you, specifically with either of the meters that we offer to you, I'd like to do it that way if I may, please. Is that okay, sir?
Yeah, it's okay.
Okay. What we have down here now is this is the controller that connects to the D-Slick 2, the digital synchronizer, and that can be a deep dive into there. But basically on the left side, you can set that D-Slick up and you can perform functions that will test it to be sure that it will take the generator into synchronization. It will lock it in, but not necessarily close the breaker or such. And then on the other side, you can do the synchronizing modes or such if you simply want to check or if you want to make it permissive or such. Each of these functions can be explained further during maybe our next presentation. You'll also notice that we can give you the emergency stop push button. And then on the bottom, there are a couple of keyed switches that are a raise lower switch that you may have if you want to simply do that manually and raise or lower those functions. Down at the bottom, you'll see that these are draw out breakers. Usually we're using an MTZ or an NW type breaker nowadays from Schneider, Square D. Back to the comparison again here. You notice on the far right side, standard UL5058 design with draw out breakers. We are building it to an ANSI standard 3720.2. When you look at the breaker amount of times you can operate that breaker, anywhere between 5,000 to 12,500, depending on the rating of the breaker, before you have to do any maintenance to that breaker. Energy reduction maintenance switch, yes. Whereas you'll notice even in the middle, the load management type system, resilient application, that is optional, but we can accommodate for you. The short circuit bracing, I've told you up to 200K. Obviously, when we look at it, we would like to do that to the least amount that you do require. We either a 65, 100, or 200K rating. Our busway is silver plated copper. We can offer tin plated copper, but that is usually done in water treatment plants and such. If you require that due to your client, please be sure that is in your specification. A witness test is recommended. The ability to select transfer switches via HMI is standard, and then the warranty, and whether it's a type 1 or NEMA 3R. We can also do NEMA 3R walk-in of some type or such. Those types of things we'd like to work in conjunction with you. Do you simply want to take NEMA 1 gear and put it into an e-house, or do you want actually some type of a sheltered aisle or some type of a walk-in construction? Please bring that to us. We would like to discuss those with you. We've sort of touched on this before, but again, depending on if you're a tier 1 data center or some type of high level clientele, you may want to have us work with this. Another comment is that we can set up our devices for future expansion into some type of a power monitoring system. It's not in the budget right now, but make us aware of that. We'll set up all of the transfer switches, all of the gear with the proper metering and such, so that at a later point, if you want to then come back with Schneider and put a PME, power monitoring expert or so, we're already set up for you. It's something we'd like to discuss with you that should you need it, let's do it on the forefront. It's a lot less expensive on the front than having it modified in the field later on. The 1558 construction here, just to give you a little bit of guidelines. First of all, you're going to get an elevation view, which will also include your conduit entry area and the size of those conduit entries. You notice again, we're back to some type of a master section with an OIT screen and enunciation and a control station that we looked at earlier. You're going to get from ASCO, you're going to get our one-line, three-line diagrams and such, giving you each of the components, how they're connected, how they operate and such for both the generator sections and each of your distribution sections. You have the ability that not only have that screen at your master control section, but you can have those remote. You can have a multiple of those remote, okay? And they can be different sizes depending on how you want that displayed. Kind of getting around to the end of this for you folks. These are some things I'd like you to walk away with, but if you look in, I had both 2020 and 2023's National Electric Code. So you reference 700.3F. If you have a temporary source and you're under a temporary source of power for maintenance, you have to have the ability of a roll-up generator. If you are doing something under 700.5D, redundant transfer equipment, okay? If it's applied by a single feeder to your 700 loads, you now have to supply either a bypass isolation transfer switch or some other means of duplication. Those are outlined in the NEC. Looking at 710B, the wiring, this one I always pose to you, and I know we have a couple of different firms online, but one takeaway is that you have to have separate vertical sections in our paralleling switchgear used to separate emergency loads from the other loads. However, reading a little bit further down, it shall be permissible to use a single or multiple feeder to distribute equipment between the emergency source and the point where the emergency sources are separated from all other loads. That's an individual to how your firm evaluates that, and we would like to discuss that with you, that when we're laying out, again, back to that elevation view, depending on your interpretation, we may be able to save you some sections, some space, and some cost or such. And then, of course, down to the bottom is one of the most stringent ones recently now. The integrity of the generator remote start circuit shall be monitored for broken, disconnected, or shorted wires. The original verbiage said that you not only had to start the generators, but you had to enunciate it. That has been taken out in 2023, but the loss of integrity to that start circuit will start the generators. So these are a few that hopefully help you. We can do our specification, and I will probably pause a little bit. Maybe Mumtaz wants to finish on some of these last few slides, please.
Yep, so at the end of whenever the guest speaker's done presenting, I will provide our specifications for the equipment we talked about on that slide. So on the left here is our traditional low voltage paralleling gear specification, and on the right there's the load management switchgear specification that you saw during the Onboard Plus section. So I have those links working. If for any reason you're not able to access it, then let me know and I can send that to you to your email. Daniel, next slide. And this is a slide I'll have at the end of every series as well. This is just some additional resources you can get at ascopower.com. It has our Revit family, some additional white papers. Next slide, Daniel. Okay, so the next time we are going to meet is March 28th, same time. We're going to keep the paralleling switchgear momentum going and talk about the design considerations to make. I may have told a few of you that the next one's going to be on medium voltage. I was getting too excited ahead of myself. That's actually going to be the one after this. We're going to wrap up low voltage switchgear and really get into the design and the stuff that Daniel mentioned earlier on the load demand and load shed before we introduce something like medium voltage, because there are different designs and very much different things to be aware of when medium voltage comes into play. So I will send out the invites for that shortly. And then next slide. And then last here is a QR code and a link for a survey. You need to do the survey. It will ask you for your information and your email, and that is how the PDH will be emailed to you. That was not my doing, that was a marketing doing. But so please complete the survey. Just give us your email information on there, and then your PDH will be sent to you. If you had a few people in your firm that had to leave a few minutes earlier, then have them reach out to me, and I can send them to their email as well. And at the end bottom there is my email and my mobile information number if you guys need. We'll leave this slide up here. This recording will be sent to you along with the slide deck and a PDF that has a snapshot of the table. So everyone will get a copy of this information that was presented here. So I'm
A
going
lot
to
of
stop the
information
recording.
was given to you today, folks. I do not expect you to retain all of it. Mumtaz is a great resource for you. Please reach out to her. The most important thing is that as you get into a specific project, then it all becomes relevant, and we want to be a resource to you. Yes, ma'am. Thank you, Mumtaz.
Yep, thank you.